Hello everyone, we are 10 team and our project is SOHO. First, let's review what we published last week. Last week, we introduced the structure of Beijing SOHO Center. Next is the list of contents this week. This week, we will introduce the Siamese structure design of a SOHO Center, including 1. Difficulty in the design of the conjoining structure. 2. Compression and selection of the connection scheme between the body and the main body. 3. The body scheme. 4. Design method. 5. Summary and 6. Study plans. 1. Difficulty in design of a conjoining structure. There are 5 connecting bridges in the project. Each will a space of about 40 m. The design of the connected bridge structure is one of the difficulty of the project compared with the general double tower conjoined structure. The difficulties in the following 3 aspects. 1. The width of the bridge between the tower is quite different. The number of bridges is different. The height of the bridge and the main body and the weight of connection with the main body are different, and different treatment facts need to be adopted. 2. The outer contour of the 4 towers of the project and the connecting bridges connecting to them are all curved. It's a conventional linear trace is used. The outer contour of the floor at the connected bridge will vary greatly, which will make the position of the tray difficult to place. 3. Due the requirement of the building's flat elevation, the connected bridge can only adopt the hollow trap structure, which requires high rigidity of the tray. 2. Compression and selection of the connection scheme between the bridge and the main body. Scheme 1, which is connection scheme. The direct connection between the bridge and the main current does not require cables, but the mutual influence between the body and the main body is large, so it will have a certain impact on the architectural layer. When the span of the bridge is large, the current connected the bridge and the main body have to be a large bending moment. Measures are usually taken to ensure the transmission of internal forces, such as adding diagonal support between 2 adjacent currents, which will affect the layer of the building. Certainly affect. Scheme 2. Both ends of the bridge are connected by sliding bearing. An expansion joint should be arranged between the connecting bridge and the main body, and the connected bridge is connected with the main body through a sliding support provided on the main body current cable. This plan requires expansion joints at both ends of the bridge, which has a great impact on the building facade. Solution 3. One end of the bridge is sliding and hinged, and one end is fixed and hinged. Only an expansion joint between the connecting bridge and the main body needs to be set at one end, and the hinge and top plate connected the connected bridge and the main body is continuous, which had little influence on the building facade. According to the specific condition of the connection between the bridge and the main body. Tower 2 and 3 are 2 tower calculation units, and the high-level bridge between the 2 towers adopt the wedge connection scheme. The other 4 bridges are all located between the 2 computing units, using a fixed hinge at the end close to the east unit and a sliding hinge connection at the end close to the west unit. 3. Bridge plan. The connected bridge adopt a steel structure or shape hollow transform. and being a dump, a windfall concrete composite floor with a profile steel plate. For play with the bridge width is small. A single spat bridge skid is adopted. The connected bridge is composed of arc-shaped hollow chassis on the both sides, and the two chassis are connected by closed beam. The core of the hollow chassis adopt H steel beam. For large bridge width, a double spat bridge skid is adopted. At this time, the connected bridge is composed of 3 hollow wheel chassis, and the chassis are connected by beam. For the plate with the middle layer is much wider than lower layer. To use the limited beam height, the plate of added color at the end of the outer closed beam is adopted to junction the rigidity of the overhanging part.
The calculation software adopts SATW and meters. The main points of the calculation of bridge are the structure calculation, the deformation check calculation, the check calculation of seismic joint weight of the sliding end, and the joint check calculation. The calculation method adopts the time history analysis method. The calculation of the joint weight of a bridge is more complex. The main calculation goes as follows. Sliding displacement of a high-level bridge between trees 3 and 4 is a largest, and the max displacement calculation goes of the input of the 3 cut of seismic waves. The waveform in the figure represents the end node and the main body of a branch X, while displacement time of the node and the corresponding position. The method of slip is a vector of 3/6 of seismic work, and the result is 405 millimeters. 5. Summary. The 5-level bridge between the trees are composed of steel beams and steel columns. Due to the long span of the bridge, there is no other support in the high air. Only the steel structure can withstand the bending structure could be on long span, and the design can be raised under constraints of economy and technology. The design of bridge takes into account the large movement of three concrete structure due to former expansion and concretion, earthquake, wind, and other natural factors. Therefore, the two ends of the bridge are supported by the curbs. The main columns, the curb on one side of the bridge is supported in the fixed manner, with the curb on the other side of the bridge providing support. Avoid damage to the structure and the human pedals of the other crudely while doing lateral movement. In the future, we will introduce the construction process, construction difficulties, and the green building.